question 9, another Euclidean geometry question. Check out the description box for other recordings for this question paper. So the question 9 is a two-part question. Kuno 9.1 where you get to prove. You need to prove this. You need to prove with theorem number 2 that angle at center equal to 2 times angle at circumference. Then there's also another question 9.2 where you get to calculate ama angles. It's basically a numerical exercise. The question 9.2. Ne? So in terms of for this recording, I'm not gonna do 9.1. I'm not gonna do 9.1. I feel I've done my videos where I improve theorem number 2. So I feel like it would be better instead of me proving it again. How about I take you to a recording only for that theorem number 2, where I get to show you how to prove theorem number 2. Let's just focus on this part 9.2. So share a link in the description box for that proof. So now sizophendula only the 9.2. Yeah. In the diagram below, DF is a diameter of the circle with center O. So this is the diameter with DF in a center O, and then we chord EG intersects with DF at H such that DF perpendicular to EG, chords EF and GF are drawn. Then EGF, angle EGF is equal to 55 degrees. This angle 55 degrees. Okay. We also have a cyclic quad. I don't know which way you want now. This one, it's a cyclic quad, right? It's a cyclic quad, of course. I don't know. Maybe we try to look at this should be connected to qualify. It is a cyclic quad. Even without this line, it is a cyclic quad. Okay, so now 9.2.1. What is it? Determine the size of the following angles. Angle D. 9.2.1. We wanna answer A. D is equal to 55 degrees. When 55, you are equal to D. You know, angles in same segment. Angles in same segment. Then go B, O2. They want us to find the angle O2, the size of O2. O2. So the O2, there's this structure for theorem number 2. There's this structure between O2 and the 55. Can you see that? I can. I hope you do. So this is an angle at center facing this way, and then 55 is also facing in the same direction. So it means that O2 is over 2 times 55 degrees. This is angle at center equal to 2 times angle at circumference. So O2 is equal to, what is 2 times 55? 110 degrees. So this is the answer, is 110 degrees. C, let's work out E2. Where's E2? E2. Now E2. What is the value for E2? E2, let me erase this part. Remember, whatever you calculate uzoyisebenzisa in some way on the second question, and then whatever you calculated la phezulu, you're also gonna calculate or you're gonna use in calculate the unknown in the next question. Okay, so silago C, they want us to calculate to E2. I have O2. I have 55. I also have Ubadi 55. Just think about it for a moment. Just think about it for a moment. Mina, I already have the answer, but ngifuna just uyicabangisise before ngikunikeze iloga i-answer. You can pause the video, do the calculation, best you replay again, best you resume the recording, best you abuku sithole kanjani. Alright, bheka ke la. This is a triangle, right? This is a triangle, and then the O2 is what? Is an exterior angle for that triangle EHO. Lana, I have 90 degrees. This H2 is also 90 degrees. I have 90 up. It also means I have 90 degrees nala, right? Check again. How do we calculate to E2? We're gonna say when E2, when combined with H2, you're gonna be equal to O2. Why? Exterior angle of triangle. E2 when H2 when equal to O2 when exterior angle. What is E2? E2 I don't know. Plus what is H2? H2 it's 90 equal to O2 it's the 110 degrees. E2 is equal to 110 minus 90 degrees. I'm thinking the answer is to give about 60 degrees, but just to double check, 110 minus 90, whoa, 60, where's 60 coming from? Yeah, 20 degrees. 20 degrees, okay, 20 degrees the answer is together. Alright, then E3, how do we calculate to E3 again? Again, you can do the same thing. E2, you can pause the video, just think about it, pause up, besuphinda ubuye futhi. Alright, again, then D E3, okay, E3, I think 70 rate. This is a radius. This is also a radius. This triangle, a rad, it means ukuthi yini i-isosceles triangle. So the opposite sides are equal. Ama radius and ama radius are equal, right? So it means that E3 no F1 bayalingana. So E3 is also equal to bani F1. Ama angles opposite equal sides. Angles opposite equal sides. Angles opposite equal sides. Okay, therefore sizoti when O2 plus E3 plus F1, you are all equal to 180 degrees, sum of angles in a triangle. So for the fact that E3 and F1 are equal, I can just change F1 and make it E3. Lana, we're gonna substitute to O2 which is the 110 plus what is E3? E3 we don't know, but F1 is also equal to E3. So I'm gonna change that to E3. So E3 plus E3 gives me 2E3 equal to 180. So making E3 the subject of the formula, it's gonna be 180 minus 110 you're equal to 70, then divided by 2 total 35. So it means that to E3 wami is equal to 35 degrees. That's the answer for E3. Alright, let's double check 55 times 2. Alright, okay, so 9.2.2, determine the length of OH. OH, where's OH? Now OH, they want us to find the length of OH. We are given that if the diameter of the circle is 10 units, the diameter, this is the diameter, is what? Is 10 units. So D, the diameter, it's 10 units, and then GE, this GE, it's a chord. It's what? It's 9.4. GE is 9.4. All right. Okay. Big. This triangle, this triangle, it's a right angle triangle, right? It's a right angle triangle. Basipe ini diameter, which means that the radius of the circle ubani 5. The radius go about 5. 10 divided by 2 gives us ubani 5. So it means that if we turn our attention to this triangle, this one, specifically this one, let me use a green. Okay. So specifically this one, sifuna OH, we want to OH, OE, go about 5. The radius, it's gonna be 5. The radius, it's gonna be 5. OH, unknown. Light's 90 degrees. How do I know? Angles on a straight line. H2, 90. H3, 90 as well. Right? So for the green triangle, so 7 sayona to calculate the OH. I wanna use the Pythagoras theorem, meaning that I need UHE. I'm gonna need UHE. So it means that UGH ulingana no HE. How do I know this? It's because of it's because of cinema perpendicular lines, and theorem 1 uti okay, line from center line from center perpendicular to chord. It's perpendicular to chord, and when a line is perpendicular to a chord, it means that the chord is actually divided into 2 equal lengths, meaning that HE uba equal to that. So since ngifuna HE, the HE uzoba equal to 9.4 divided by 2. 9.4 divided by 2. So sizothi 9.4 divided by 2. Sithola ukuthi it's 4.7 units. So sino 4.7 lana, we can now work our round in getting OOH. So Pythagoras ke kule triangle ga, in this triangle EOH, we're gonna apply Pythagoras theorem. So sizothi EO squared, hypotenuse squared, is equal to side squared, which is the OH, plus the HE squared. What is EO? 20, no, 5. EO, it's the radius, it's 5. It's 5. So it's gonna be 5 squared equal to what is OH? I don't know. Plus what is HE, which is calculated to 4.7 squared. So 25. What is 4.7? 4.7 squared. 4.7 squared. So it's 25 la, equal to OH squared plus 22.09. And then we transpose, go about 25 minus 22.09 equal to OH squared. 25 minus 22.09. Then sibano 2.91 equal to OH squared. Then we take the square root of 2.91. Sithola 1.71 units. That is OH. Well, Lago Euclid, if they want you to calculate a length of some sort, most of the time you're gonna be using a theorem 1. You're gonna be applying a theorem number 1. So I hope you enjoyed this question 9. Check out the description box for more recording in for this paper. Now we enjoy the content, leave a like, like and share, subscribe as well. So for now, asibonana on the next recording. Bye bye.